Hi students, my dear friends. Today we will discuss about in chemical bonding ionic bond formation. How to form ionic bond? What is the definition of ionic bond? Okay, here ionic bond definition. What is that? Ionic bond means the force of attraction between two oppositely charged ions. Force of attraction between two oppositely charged ions. We will call ionic bond. Two oppositely charged ions, how it will be formed? So one is a cation, another one is anion. So formation of anion, how it will be formed, and cation, how it will be formed, we will discuss. So what is the favorable conditions for formation of ionic bond? So some favorable conditions is there for formation of ionic bond. That favorable conditions also we will discuss today. So now ionic bond means ionic bond are electrovalent bond. So ionic bond means the force of attraction between two oppositely charged ions is known as ionic bond. So that is also known as ionic bond. So ionic bond formation generally first A and second A group of metals and non-metals 17th A group or 16th A group. 16th A group between ionic bond formed between first A comma second A group elements and 17th or 7th A 6th A 6th A or 16th same 16th group and 17th group elements of first A and second A group elements and 16th A and 16th group and 17th group, between them only ionic bond generally formed between these four groups. So first A and 7th A, first A and second A, and 16th A and 17th A group elements. What is the first A group elements? First one. First A group elements: lithium, sodium, potassium, rubidium, cesium, francium. That is the first A group element. And second A group elements, what is that? Beryllium, magnesium, calcium, barium, strontium. That is second A group elements. And then 16th and 17th. 16th group means oxygen family. 17th A group means chlorine, fluorine, bromine, iodine. That and all. So between them only maximum ionic bond formed between these four groups. So generally ionic bond formation is known as redox process. What is that? Redox process. What is the redox process? Redox means first reduction and oxidation. Both are reduction and oxidation, both are present in one reaction is known as, that is the redox reaction. So this process is the redox process. They said, what is the redox process? Redox process means what happened? First, oxidation means what? The addition of oxygen is known as oxidation. Removal of removal of electrons is known as oxidation. So removal of first amount Mg gives less to Mg plus 2 electrons. So this is oxidation process. So removal of electrons we will call oxidation. Removal of electron from neutral atom, 2 electrons we can remove, that is known as oxidation. So next reduction means gain of electrons. How? F is there, plus 1 electron gives less to F minus. So here addition of 1 electron to neutral atom we will call, that is redox reaction. So reduction, oxidation takes place, we will call redox process. So where it is happened? Ionic bond formation. So ions will be formed, Mg plus 2 ion, F minus. Both between bond will be formed, means that bond is known as ionic bond. So that bond is known as ionic bond. So formation of ionic bond, some favorable conditions also is there. Here redox process I said. Redox process means what? Ionic bond formation is redox process. Why I call redox process? Here addition of oxygens is there, removal of oxygen is there. So addition of oxygen we will call reduction. Removal of electron we will call Oxidation, addition of electron, reduction, removal of electron, oxidation. So oxidation reduction takes place. That's why this process is known as redox process. So here formation of ionic bond, some favorable conditions is there. So some favorable conditions. So in this favorable conditions for formation of cation. Now this is first subheading. What is that? Factors favorable for formation of ionic bond. In the ionic bond formation means we want two types of ions. So one is cation, another one is anion. So now favorable conditions for formation of cation. First cation will be formed, then only anion we will go for that. So now favorable conditions for formation of cation. So first favorable condition, how to form cation. First favorable condition, what is that? Atomic size are, so some favorable conditions is there. In that first one, low ionization potential. Low ionization energy or ionization potential. Low ionization potential elements. That is first favorable condition. The second favorable condition, low charge on the ion. Second one, low charge on ion. Low charge on ion. Next, first low ionization energy and low charge on ion. And third one, large large atomic size. One more thing is there, large atomic size. And fourth one, octet configuration. Octet configuration atoms. Some octet configuration atoms are very stable. Octet configuration or inert gas configuration. Inert gas configuration. Inert gas configuration elements. So these four favorable conditions. These four favorable conditions for formation of cation. This one, cation formation. These four favorable conditions. First one thing we will discuss one by one. Low ionization energy. So yes, low ionization energy means what? The first ionization energy means what? The minimum amount of energy required to remove an electron from gas state neutral atom, outermost electron. So outermost electron is there. So outermost electron, this is outer shell, last shell. This electron we can remove means how much energy required. That energy is known as ionization energy. So that energy we will call ionization energy. The minimum amount of energy required to remove an electron from gas state outermost electron, we want that is ionization. So which atoms having ionization energy very less? Which atoms having ionization energy very less? That atoms we will call, that atoms are favorable conditions for formation of cation. So which atoms? Simply, which atoms? See, first year group we will take example. First year group, lithium, sodium, potassium and rubidium, cesium is there. So lithium means only 2 shells is there. Potassium means only 3 shells is there. Yes, Amma. 3 shells, 2 shells means what? Atomic number 3. 1s2 and 2s1. That is a 2 shell. First shell, second shell. For this one, 11 atomic number. 1s2, 2s2, 2p6, 3s1. So third, 3 shells is there. This is sodium nucleus, 3 shells. Same potassium also 4 shells is there. Next, rubidium 5 shells is there. 5 shells. So cesium, how much? Like 6 shells, 7 shells, 6 shells is there. So like this one. So here to here distance, so here to here, here to here, here to here, nucleus to valence shell. Distance how much? Which is more? Cesium is more. That's why here electron we can remove very easy compared to here electron, lithium electron, because nucleus attraction on outer electron very less in cesium. Nucleus attraction is very less. Nucleus attraction is very less on outer electron because here large size atom, that also is there, large size atomic, large size atom. That's why we can remove very easy. We can apply low ionization energy, less energy also it will remove. It will form a cesium plus ion. Cesium plus ion. This one is nucleus attraction very high compared to this one. We didn't remove easily this electron. This lithium not a favorable condition for formation of cation. Cesium favorable condition for formation of cation because low ionization potential. So cesium want very less energy. It will remove their electron, outermost electron. Okay, ma? That is the reason. Next, second one, low charge on ion. What is low charge on ion? Low charge on ion. Ion low charge means what? See, charge. For example, Al plus 3, Al plus 3 and Mg plus 2 and Na plus. So your charge, see, which is a low charge? Low charge means single charge. Which is single charge? This is compared to this one. So Na plus single charge is favorable condition for formation of cation compared to the plus 3 plus 2. So plus 1 means only one electron we can remove from neutral atom. Only one electron we can remove means it will be favorable condition for formation of plus charge. And one more electron we can remove, somewhat difficult. Compared to this two, this is very easy. Compared to this two, this is somewhat easy. So that is the reason, It is a low charge on ion. That means single charge. Next one, large atomic size. Yes, before only we discussed large atomic size means cesium is the large size and rubidium, Rb, after potassium, after sodium, after lithium. So large size favorable condition when we can increase temperature or we can give energy which is responding very easily. This is the response very easily. That means this one loses their electron very easily. It will form a cation compared to remaining because this is a outer electron attraction very less in this because big size. So easily that is a favorable condition for formation of cation. That one. Next, inert gas configuration. Here inert gas configuration is easy to form a cation. What is that? For example, Zn and Ca plus 2, Zn plus 2 is there. So this is a 30 atomic number. This is a 20 atomic number. Minus 2 plus 2 means we can remove 2 electrons. Here 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2 also is there because 20 plus 2. So plus 2 means we can remove this one. Now this is 8 electrons is there. Next second shell also 8 is there. First shell only 2 electrons is there. So 2 electrons 8. Valence shell 8 means it is a most favorable condition for formation of cation compared to this one. This is the 30 atomic number. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 10. Here we can remove last shell 2 electrons means here Zn have 2 comma 2 comma 2 plus 6 plus 2 plus 6 8. 8 will come 2 comma 8 comma 18. So this is not a valency, octet valency. That's why it is somewhat difficult to formation of cation, but Ca plus is mostly ionic character than Zn. So this is about cations. This is about formation of cations. Now formation of favorable condition for formation of anion. Some favorable conditions is there. We will discuss that favorable conditions of anion. So favorable conditions for formation of anion. First one, high electronegativity. First one, high electronegativity. Second one, low charge on ion. Low charge on ion. Small atomic size. Third one, small atomic size. So these three first we will discuss. Here, high electronegativity. High electronegativity or electron affinity means, before we discussing ionization energy, how ionization, the amount of energy required to remove an electron from neutral atom, gaseous state, neutral atom, outer shell electron, how much energy required for removing outer electron. No, same here, how much energy released when an electron is added to neutral atom. For example, fluorine is one neutral atom, so this one have 2 shells. So we can add this electron to that atom means how much energy this one releases for adding this electron, how much energy releases, that is we will call electronegativity. So electronegativity, actually what happened, electronegativity left to right increases in periodic table. So oxygen, nitrogen, oxygen, fluorine. So this is electronegative atoms in a one period. So which is more electronegative nature here? So left to right I said, no? So more electronegative. Fluorine is highest electronegative than oxygen. Oxygen is highest than nitrogen. So this is the highest electronegative element, because here size of these three we can compare means F size is small. So when we have to add electron, this one easily adding that electron, easily accept that electron. So that is the favorable condition for anion formation. Accept that electron means it will change into F minus easily. So which is easily accept electron, that is known as electronegative element. Mostly electronegative element that will form a anion. So size is small, that's why here attraction is more, because the size is small. Here attraction is somewhat high, attraction is less. Here attraction is less because size is more. Here attraction is very high because the size is very less. So that is the order. Next point, favorable condition for anion formation, low charge on ion. Low charge on ion, for example, N minus 3 comma O minus 2 and F minus. So in this 3, which is low charge, F minus formation is very easy because that is anion formation. F minus is more than O minus 2 and N minus 3. So low charge on ion, favorable condition for formation of anion. That is low charge means single charge. Electron we can add one electron, means it will accept easily electron, compared to the 3 electrons we are adding, 2 electrons we are adding, very difficult. Next, small atomic size. That only we are discussing. Small atomic size. What is the small atomic size? Nitrogen, fluorine, nitrogen, oxygen, fluorine. This is a small size because size of the same shell. One minute. This is atomic number 7. This is 8. This is 9. How you know, sir? Size is small this side to that side. So now I will say size. Nitrogen atomic number 7, 1s2, 2s2, 2p3. Same second shell. Here also 1s2, 2s2, 2p4. Here also 1s2, 2s2, 2p5. Here small change. Here total 4 plus 2, 6 electrons is there. Here 7 electrons is there. Here 5 electrons is there. Valency. What happened? Nitrogen 2 shells. 5 electrons is valence electron, 2 electrons inside electron. Oxygen, for oxygen, 4 electrons, 4 not 6 electrons valency, 2 electrons inside. For fluorine, 7 electrons, 5 plus 2, 7 electrons valency electrons, 3 plus 3, 6, 7, inside 2 electrons is there. Now see, size why I wrote like this decreasing, because same shell, second shell, all have second shells, 2 shells only, but here number of electrons more, yes sir, compared to these electrons. Here number of electrons more. What happened? Number of electrons more means neutrons also more, protons also more. Protons also, here 7 protons is there inside the nucleus. Here oxygen protons, 6 protons is there. Protons, 8 protons is there. Here 9 protons is there. Here 7 protons. Atomic number only protons, no? That's why. So these 9 protons concentration is more. That means here 7, here 8, here 9. So nuclear charge we will call that is nuclear charge. 7, 8, 9. Which is more? 9 is more. So nuclear charge is more here because fluorine atomic number 9. Number of electrons, valency electrons only 7 valence electrons, but 9 protons inside is there. Inside the nucleus 9 protons is there. So 9 protons charge we will call nuclear charge, that is positive charge. That positive charge is increases. Nuclear charge increases, atomic size decreases. So nuclear charge here 9, atomic size, that's why I wrote small. So nuclear charge increases means that surrounding that area we will call that is that boundary. 8 electrons is there, no? 7 electrons is there, no? That 7 electrons, this nucleus will pull the electrons inside. That means that atom will be somewhat contraction will be there. The contraction is somewhat decreases atomic size because of nuclear charge is more. That is the reason. So small atomic size is formation of anion very easy, because one more electron we are adding means easily it will accepting. That is the reason. Okay, thank you. Thank you all of you.